So the next thing that I'd like to look at is some modulation effects. So modulation allows us to apply some kind of variation to our sounds. Typically, we are going to apply modulation directly to the sound as an insert, just like we have applied EQ and compression. The reason for this is because the three types of modulation that we're going to look at all behave in a similar way. They split the signal into two parts, an original line and then what we call the delay line. The delay line is where we will effectively alter the signal. These two lines will then be added back together so that it creates our affected sound. So I'm just going to use this house example. So this is what it sounds like. And you can see we've got a bit of EQ and a bit of compression on there. Nothing else really. But what I want to do is I'm going to go to this pad sound. Just here. I'm just going to isolate this. I'm going to just play through a bit of the track and I'm going to add a modulation effect to the pad. So the first one I'm going to look at, I'm going to go down to modulation. Here are the different modulation effects that come with Logic, and the first one I want to look at is chorus. So chorus gives us a gentle widening of the sound. The signal is split into two, as mentioned. One side is then slightly detuned and delayed before being added back into the signal path, mixed back together. The delay that is applied to the delay line is somewhere between 20 and 50 milliseconds, so it's quite quick. It's not like we're going to hear it, but it's going to give us the effect of width. So if I play this, so whereas before we had a dry and a wet, this has got a mix. So D mode, direct mode, that would be 100%, so all effect. So I'm going to leave it like that to start with so that we can hear all of the sound. If I bypass it and just press play. So that's the sound that we're working with. You can hear it's got a bit of movement on it already. So we have 100%, effectively this, with direct mode. The intensity is how much these two elements are going to interact with each other. So how intense the movement is between the two lines. The rate is effectively how we get it to pulse in time. So we can do a little formula to achieve this. And it is 60 divided by the BPM of the project. And this will give us our rate in hertz to make sure that this pulsates in time. So 60 divided by 120 is 0.5. Now you could have half of this value or double of this value and it would still technically be in time, in the same way of having half the tempo or double the tempo would be effectively the same time. So 0.5 or 0.25 would get this to pulsate in time. So 0.5 to start with. If I press play and we bring the intensity up, it's very, very subtle. But what you can hear is it's wider. And if I alter the rate, you'll hear this now. And you hear it pulsating from left to right because they're almost out of time. If I bring this back, so that's in time. So is that? It should be 2.5 or 0.25, but that's as close as I can get. And if I bring the intensity down, and really what we should do is get it to a value that we want. And then dial back the mix so that we have some of this affected sound now blended with our original. Okay, so I'm going to leave the chorus. I'm going to leave it on that sound. Let's see what else we've got. So we're going to use the piano. It's because it's another nice sound. So yeah, this time we'll have a look at the phaser. So again, the signal is split into two, the normal line and the delay line. The delay line has its phase shifted, and then they are laid back on top of each other, because you have two opposite phases of the same note. A kind of a notch is created, and this is where the sound cancels itself out. If you've looked at anything to do with phase, you'll know that this is cancellation of sound. So these notches are then sweeping across the frequency range, and this is what gives us this kind of rippled effect. So again, if we do the mix 100%, and if we already know that we could have 0.5 and 0.25 is in time, let's do the amount of feedback. So they can really hear it now. Obviously that is too much. If I bypass it, so it's subtle, but it's nice. It's a very, very common effect for guitars, guitar solos. So the final one we'll look at will be our flanger. This is my favourite of the three. So flanger being not too dissimilar to a phaser, but it is much bigger sounding. So the flanger happens again when the signal's split into two. One is delayed and then put back on top of the other. It's generally about 20 milliseconds difference, but they start to sound really nice at about 15 milliseconds. So the general effect of the flanger is a long sweeping sound. So again, the feedback is how much we hear. The mix is the balance between the two. The rate is how it is pulsating in time. So I can go 4 bars, a quarter, half. If we have it on 4 bars to start with, and we put the feedback and the mix down slightly. So if I start to bring the mix up and the feedback, so all three of these types of modulation help to give a bit of movement, variation to the sound, all being essentially time bound to our project.